In today's class, we're going to solve questions on chi-square distribution. If a die is tossed 36 times and the spots obtained are given below, we have the face shown and the spot obtained as F0. We are asked to set up an hypothesis test. Okay? Don't forget that chi-square distribution is a continuous probability distribution that is used in many hypotheses. Okay, so now I want you to pay attention. This FO is the observed value. Observed. Okay, are you paying attention? This is the face that is shown. You know that the die is thrown in 36 times. You understand? So this FO is the observed value and this FE is the expected value. Expected value. Okay, so now we cannot set up an hypothesis test without determining our expected value. Do you understand? So now to calculate the expected value, I'm going to sum up all the observed base that is shown. You understand? You don't forget that a dice has how many face? 6 face. You understand? So I'm going to sum up all the observed face that is shown. Then I'm going to divide it by the count of all. You understand? For example, look at this. I'm going to sum up FE will be equals to 6 plus 2 plus 8 plus 9 plus 5 and plus 6 all over 1, 2, 3, 4, 5, 6 all over 6. So the expected value is equals to 36 divided by 6, which is equals to 6. So for this, the expected value for all the face shown will be what? 6. Do you know the reason? The reason is because the probability of obtaining a face out of the 6 face of a die is 1 over 6, and it will be the same for every of the expected value. Do you understand? Please, it is very, very important that you understand this. The probability of obtaining only a single face, don't forget that a die has 6 faces. You understand? The probability of obtaining the first face is what? 1 over 6, which will be equals to the probability of obtaining the second face, which is 1 over 6 also. You understand? So let us proceed. So having gotten the observed and the expected value, don't forget that the calculated chi-square is given by this formula: summation of the difference of the square of the observed and the expected value divided by the expected value. And in the question, we have been given that the critical value, that is the tabulated chi-square at 5%, is 11.07. So in order to set up an hypothesis test, I need to determine the value of my SC, which is the calculated chi-square. So from this formula, I need the difference between the observed and the expected value. Do you understand? So another column, I'm going to have FE minus, the observed value minus the expected value. You understand? So let's take the difference. This is the column for the observed value and this is the column for the expected value. So the value of this cells will be 6 minus 6, that is 0. The value of this cells will be 2 minus 6, that is minus 4. The value of these cells will be 8 minus 6, that is 2. The value of these cells will be 9 minus 6, 3. Then the value of these cells will be 5 minus 6, that is negative 1. And the value of these cells will be 6 minus 6, that is what? 0. Please, do you understand how I got this? If you didn't understand, kindly reverse the video and listen to the explanation again. You see, this formula is what is used in calculating the calculated chi-square. Are you get what I'm saying? But I need the calculated chi-square. I want to compare it with the tabulated chi-square, that is the critical value at 5%. But in order to compare it, I need to determine the value, and this is the formula that I'm going to use. Okay, and from this formula, I need to take the difference between the observed and the expected value. You understand? That is what I first did. I'm just dealing with this numerator. I've not touched the denominator at all. Okay, so let us proceed. Now from this formula, I still need to square the difference. Okay, I need to square the difference between the observed and the expected value. So the next column will be FE, the observed value minus the expected value squared. Okay, please, can you see what I wrote here? That is the square of this difference. That's what I put here. Okay, so now let's proceed. 0 squared will be what? 0. Minus 4 squared will be 16, okay? And for this, I'm going to have 2 squared, that is 4. 3 squared is 9. Minus 1 squared is 1. And 0 squared is what? 0. Do you understand how I got this? Having taken the difference, I square the difference, okay? Now, the next column will be the entire formula. You understand? That is FO minus FE divided by FE. You understand? FO minus FE squared divided by FE. Don't forget that I've already taken the square of the difference between the observed value and the expected value. Now, the next thing I'm going to do is that I'm going to divide all this value by the expected value. You understand? And this is the column for the expected value. So let us proceed. For this, I'm going to have F observed, face observed minus the face expected squared all over the face expected. Do you understand? Just like taking this formula, okay? So, and I've already squared, this is the face expected square. So, I'm going to divide all the value in this column by the expected, okay? So, for these cells, that will be 0 divided by 6. 0 divided by 6, that is what? 0. Do you understand? Okay? So, for these cells, I'm going to have 16 divided by 6. 16 divided by 6, that is what? If you want your calculator, you're going to get 2.66. 2.667. No. 2.6667. Okay? Can you see my writing? Okay, for this cells, I'm going to have 4 divided by 6. 4. What happened to this marker? 4 divided by 6. 4 divided by 6. That will give me 0.6667. 0.6667. Okay? So for these cells, I'm going to have 9 divided by 6. That will be what? 9 divided by 6. That will give me 1.5. 1.5. And for these cells, that will be 1 divided by 6. So 1 divided by 6, that is 0.1667. 0.1667. Please, do you understand how I'm getting the answer? You know, this is the difference. I have already squared the difference. This is the square of the difference. I'm only dividing this square of the difference by the expected value. And the expected face that the expected value, which is the expected face shown, is what? 6666. Is that not it? So I'm dividing this value by this value. So for this cells, I'm going to have 0 divided by 6. That is what? 0. You understand? So from the formula of chi-square, I need to sum all this. Okay? I need to take the summation of all this. If you take the summation, you're going to get 5. 5.00. You understand? So the calculated chi-square, which is SC, the calculated chi-square is equals to 5.00. Now, look at this. I want to ask you a question. Between the calculated chi-square and the critical value, which is the tabulated chi-square, which one is greater? Don't forget that the critical value is what? 11.07. The critical value is also known as the calculated chi-square. I want you to take note of that. The critical value is also known as the tabulated chi-square. Okay. So now look at this. I want you to check which of this is greater. Is it the calculated chi-square or the tabulated chi-square? Of course, the tabulated chi-square is greater than the calculated chi-square. So in that case, I'm going to accept the hypothesis, okay? The hypothesis will be accepted. But in a case whereby you calculate your, after calculating your calculated chi-square, you will realize that it is greater than the tabulated chi-square. In that case, we are going to reject the hypothesis. Do you understand? Okay, I want to note something. So 11.07 is greater than 5.00. So we are going to accept this hypothesis. Okay, we are going to accept this hypothesis. Look at this, because that means that the tabulated chi-square is greater than the calculated chi-square. You understand? So that is the final conclusion of the test. See you in the next class.